Acha, acha. Okay. Okay, so it is exact 12:45. Let's start. So Pragya, last class कौन को discuss पढ़ा है को? Hello.
सर हाँ सर सर मैग्नेटिक वेक्टर पोटेंशियल इलेक्ट्रिक स्केलर पोटेंशियल एवरेज वैल्यू ऑफ पॉइंटिंग वेक्टर आज क्वांटम फिजिक्स पर स्टार्ट हो
Okay, ठीक है. So let's start our new module. That is your quantum physics. Okay. So this quantum physics, or we can say quantum mechanics, is kept in module 5. Okay. So now question is you all have to write what is the need for quantum mechanics. Okay. What is the need for quantum mechanics? A historical review. Okay. So I want to uh, just 1 minute. I want to join my course. Okay. Is it visible? Hello.
यस सर
ये सब सर म्यूट हो गया है।
सर आपण म्यूट है
Hello.
यस सर।
So right, need for
सर
quantum
इको हो
physics. କହୁଛି
Yes, sir, echo ହଉଛି।
ତାହେଲେ ମୋ ସିଷ୍ଟମରୁ ଲିଭ୍ ହେଇଯାଉଛି ସେ ମୋବାଇଲରେ କ୍ଲାସ୍ କରିବା
Okay, sir।
ନା କଣ କଲେ ଇକୁ ବନ୍ଦ ହବ?
सर गोटे म्यूट कर
सर
दियंतु।
गोटे म्यूट कर दियंतु आ गोटे ऑन रखन
ନା ଗୋଟେ ତ ମ୍ୟୁଟ୍ ଅଛି ଏଇଟାକୁ ଆଚ୍ଛା ଏବେ ଶୁଭୁଛି? ହ୍ୟାଲୋ
यस सर।
यस सर।
यस सर यस सर
ଏବେ ଠିକ ଶୁଭିଲା।
ଏବେ ଏବେ ମ୍ୟୁଟ୍ ହଉଛି କି?
No, sir.
No,
नो सर
Okay, so this is you write need for quantum physics. Look, hello, right? Now audible?
Yes, sir.
Look,
यस सर।
need for quantum physics. Okay, so this is a historical review. A historical review. A historical. A historical review. Okay, so need for quantum physics, a historical review. So why quantum physics is required? All of you listen very carefully. Okay, I am not detecting. All of you listen. Okay, am I audible?
यस सर
यस सर।
Okay. As I said, physics are of two types. One is classical physics and second one is your modern physics. The physics prior to the year 1890 is known as classical physics. And the physics after 1890 is known as modern physics. Okay? So after 1890, okay. So what will happen towards the end of the 19th century? All of you listen very carefully. Towards the end of the 19th century, the classical physics had attained near perfection and had a tremendous success both on theoretical and experimental things. That means towards the end of the 19th century, your classical physics has a great success, both in theoretical and in experimental part. Okay, so the people, or we can say the scientists, the physicists, thought that this is the end of the physics. We don't require the further development of the physics. Whatever the things we thought, that is sufficient. But many new phenomena observed during the last decade of the 19th century, okay, and the early part of the 20th century. So that new phenomena could not be explained by the classical physics. Okay, so in order to explain the new phenomena, the concepts of classical physics were modified in favor of new revolutionary concepts. So this new revolutionary concept gave birth a new physics which is known as quantum physics. Okay, understood? Understood or
Yes,
not?
Yes,
sir.
sir. Yes,
Only
sir.
Yes, sir.
thing is, yes, the classical physics towards the end of the 19th century, people thought that there is no further requirement of the physics. But at the beginning part of the 20th century, many new experimental phenomena, new problems had reached in our society, so that new problems were not solved by the classical physics. So, so what happened? Uh, the concepts of classical physics were modified in favor of new revolutionary concepts. So this process gave birth a new physics which is known as quantum physics. So during that time, that means the early part of the 20th century, the many physicists like Max Planck, Einstein, Niels Bohr, de Broglie, Heisenberg, Schrödinger, Dirac, Born, so many physicists are there who modified the classical physics, who modified the concepts of classical physics and gave the new revolutionary concepts which gave birth a new physics which is known as quantum physics. ये समझ में आया?
Yes, sir.
Yes, sir.
So this is the historical review. The quantum idea was first introduced by Max Planck in the year 1900. Okay, so the quantum idea was first introduced by Max Planck in the year 1900, 1900. So he explained the energy distribution in the spectrum of the black body radiation. Okay, so this idea was later successfully explained by the Einstein. Okay, what? And Einstein gave a completely a different phenomenon, that is photoelectric effect. So we shall discuss that. Okay. So first the quantum idea was given by whom? That is Max Planck. This is Max Planck. Planck. On which year? The year 1900. समझ में आया? The quantum idea was first introduced by Max Planck in the year 1990. 1900. Okay. So quantum physics is nothing. We can say this is the what? We can say what is quantum physics? What is quantum physics? Now we can say.
Modified classical physics.
Yes, very good. Okay, this is nothing. The modification of the classical physics. Okay, classical physics were modified in favor of new revolutionary concepts. Okay, So that modification of the classical physics, we can say, the modification of classical physics modification, is it visible? So
Yes, sir.
modification of classical physics gave birth a new branch which is known as quantum physics, or we can say quantum mechanics. Okay, so if you say, if you go, if you say the definition, I can say, so it is the size of the very, very small things. Okay, so basically in classical physics, large object. So here quantum means it is the study of very, very small objects. Okay, understood? So you can write,
Yes, sir.
it is the study of very, very small particles. The study of very, very small particles. It explains the behavior of matter and its interpretation with energy. Are you writing?
Yes, sir.
It
Yes, sir.
explains the behavior. It explains the behavior of matter and its interpretation with the energy. Interpretation with the energy on the scale of atomic and subatomic particles. Atomic and subatomic particles.
Sir,
Sir,
and
on
it's
this,
It explains the behavior of matter and its interpretation with energy on the scale of atoms and subatomic particles. Atoms and subatomic particles. Okay, so here I want to give a difference between classical physics and quantum physics. So on the left hand side you write classical physics, the right hand side you write quantum physics. Okay, sometimes 2 mark question asked, find, write a difference between classical physics and quantum physics. Okay, are you writing? Pragya?
yes, sir.
Okay. On the classical physics part, you write it is deterministic in nature. It is deterministic, M-I-N-I-S-T-I-C. It is deterministic in nature. So deterministic classical physics gives you the exact thing. That is the deterministic. But quantum physics is probabilistic in nature. It is probabilistic. Probabilistic. It is probabilistic in nature. It is probabilistic in nature. It is deterministic in nature. It is probabilistic in nature. Deterministic in nature. Okay? Soumya, are you writing?
Yes, sir.
Okay. So number 2, here it is the study of macroscopic particles. You can say it is the study of macro. Macro, it is the study of macroscopic particles. Macroscopic means very, very big particles. And here it is the study of microscopic. the microscopic particles. The particles which cannot be viewed in our naked eye, that is the microscopic particles. Okay? Tawfiq Kumar. Tawfiq, are you there?
Tejas
Just
Singh,
sing.
Yes, sir.
are you writing or
Are you
not?
writing or not?
Yes, sir. Writing.
Okay.
Okay.
So we
So we
discussed the 2
discussed the two
points.
points.
Yes,
Number
sir.
3
Number
सर
3
point.
पुणी
point.
इको ହେଲା
सर फिर
इको
से
हो रहा
इको
है।
हो रहा है.
Okay. Number 3 point. Number 3 point. We write particles and waves are different entities. Number 3 point is particles and waves are different entities. TITIES. So, in classical physics, we are saying the particles and the waves are different. But your quantum physics said that particles and waves are same entity. So,
सर डिफरेंट
in different entities, En, Pi, Ti, Es. But here you can write the particles and waves are same entities. Particles and waves are same entities. Okay. Number 4 point, right? It does not accept dual nature of radiation. It does not accept dual nature of radiation. That means the classical physics does not accept the dual nature. Dual means dual, two type of radiation.
Light
Okay.
and wave.
Yes. But here it accepts the dual nature of radiation. Which one? The quantum physics. Quantum physics accepts it accepts it accepts dual nature. It accepts dual nature of radiation. It accepts dual nature of radiation. Okay. So these are the 4 points you have to mention on your exam paper. Okay. Understood?
Yes, sir.
Yes, sir.
Okay. So it does not accept the dual nature of radiation, but quantum physics accepts the dual nature of radiation. Okay. So next give the heading particle aspects. Particle aspects. Particle aspects of radiation. Particle aspects of the radiation. So basically there are three experimental, not three, 5 experimental things which explain about the particle nature of the radiation. Means from that experiment we can say the particles are present. Okay. So what are the three? First we have to study the three experimental things. The first one is black body radiation. This is black body radiation. Number 2 is photoelectric effect. Photoelectric, ठीक से लिखा ELECTRIC, photoelectric effect. Number 3 रहुची Compton effect. Compton effect. So these three experimental things explain about the particle aspects. Remember, this is particle. The particle aspects of the radiation. So as per the new syllabus, black body radiation is not in your syllabus. Okay. Previously it was there. Okay. But just I want to say about the black body radiation. So black body means the body which absorbs light of all frequency. Okay. So it is one which absorbs all means 100% electromagnetic radiation incident upon it. Okay. So the black body is neither reflect nor transmit, but it is a good observer or emitter. Okay. So am I audible?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So what is the black body? Already I told you. Who can explain what do you mean by black body?
Sir, a body which absorbs light of all frequency and it neither emits or not absorbs energy.
Yes. Neither reflects nor transmits. So that is known as a black body. Okay. So right. Black body means it is one. You can write the body which observes body body which absorbs all. All means 100%. Which absorbs all electromagnetic radiation. All electromagnetic radiation incident upon it. Incident upon it. So the body which absorbs all electromagnetic radiation, body which absorbs all electromagnetic radiation incident upon it is called black hole. We have, that means the total 100% of electromagnetic radiation will be absorbed by the body. So in real case, in actual practice, there is no body which is perfectly black body. Okay? And the important property of the black body is it neither reflects nor transmits. It is a good observer of radiation. Okay? So this is not in our syllabus. Okay? So next we have to discuss what is photoelectric effect. The second experiment is photoelectric effect. So this is a very beautiful experiment performed by Einstein. Okay. So he said that, all of you look here, suppose this is a metal. Okay. This is a metal. If light of suitable frequency is incident upon this metal, then what will happen? The electrons will be removed from the surface of the metal. So this phenomenon is known as photoelectric effect. Okay. So note down what's the definition. The phenomenon of emission of electron. The phenomenon, it is a phenomenon, very instant process. The phenomenon, some metals, not all metals. from the
Sir,
surface
the phenomenon of emission.
emission of electrons. Phenomenon of emission of electrons from the surface of some metals, when light of suitable frequency is incident upon it, is called photoelectric effect.
Sir, incident.
Upon it is called photoelectric effect. Sonila, are you there? Subhalakshmi? Kumar Chidanandam?
Yes, sir.
Read the statement.
Photoelectric effect, the phenomenon of emission of electrons from the surface of some metals when light of
Is called as photoelectric effect. So that means, don't think that all metals. So there are certain metals upon which, if light of suitable frequency means that is a photon. I shall tell you. So this is the light, or we can say gamma ray. Okay, that is the photon. Okay, it is known as, you draw this diagram. This is the metal surface. So this is an electron. This is the free electron. You know, all objects consist of atoms and molecules. Each atom has a nucleus. They are revolving around the nucleus. So since it is a metal, n number of atoms are present, and similarly n number of electrons are present. So when you incident the light or you can say photon, when a light of suitable frequency is incident upon it, that means the photon is one particle. So photon is coming and interacts with electron. Then the very clever electron receive the energy from the photon, not a proton, I am saying photon. And after receiving the energy,
सर सुइटेबल फ्रीक्वेंसी का मतलब क्या है?
suitable frequency means, don't think that you bring the torch light or your candle light, you incident upon iron, the electrons will be emitted. No, we have to choose a suitable frequency. That suitable frequency is known as threshold frequency. Means the light having very high frequency. Okay, so there are different frequencies of different light. So we have to select those light having very high frequency. If that light interact with the electron, then only electron will be removed, okay, from the surface of the metal. So this entire process is called as photoelectric effect. Okay, understood?
Yes, sir.
Yes, sir.
So, right. Okay, acha. Already you have written the definition. Next, you draw this diagram. This is the metal surface. The electrons are present. So the photon is coming. After receiving the energy from the photon, immediately electron leave that place. Okay. Suppose I can say, Samya, what is the room number in a hostel?
Sir, I'm hostel sir only.
Hostel the pillar na ko परिचय. You are staying in hostel. Is not responding. Dipanshu,
Sir.
you are staying in hostel.
Yes, sir.
So let Ashirvad, you also stay at hostel. Because
Yes, sir.
you are staying in hostel.
Yes, sir.
Okay. Let I have to take the interaction between Dipanshu and Vikas. So Vikas is staying at his room and Vikas has been slept. So it is early morning. The very close friend of Vikas named as Dipanshu. Dipanshu come and knock the door of the Vikas. When Vikas saw that, Dipanshu brought the very delicious breakfast for him, as both are very good friends. Okay. So when the Dipanshu saw that breakfast for him, so what will happen? What will be happen? Just you guess and tell me. Kumar Chidananda,
Hello.
Ruturaj. हाँ यस
हाँ यस सर.
क्या इतना टाइम लग रहा है
हाँ
रे
सर,
चिदानंदम
प्रॉब्लम हो गया था नेट थोड़ा.
ये तो एक ही है प्रॉब्लम हाँ because
Yes, sir.
so you are suppose let you are at your home Dipanshu has brought very delicious breakfast for you knock your door when you will see that Dipanshu has brought the breakfast for you so what will happen immediately so immediately you brought that you will bring that breakfast from Dipanshu and will run away will leave your room isn't it
Yes, sir.
okay so same thing is here inside the metal the free electrons are present when the photon will come and interact with the electron will receive the energy after receiving the energy immediately the electron will run away okay so this phenomenon is known as photoelectric effect this phenomenon is known as photoelectric effect okay so next right the electrons so emitted so this is all photoelectrons that means the electrons so emitted are called the photoelectrons as you know due to the free electron current will be developed in the circuit so if you join the current which is known as photoelectric current which is known as photoelectric current okay so the
Sir, the
emitted
current.
electrons are known as the current developed in a circuit the current developed in a circuit which is called photoelectric current so that photoelectric current I can take the symbol as IP so IP means photoelectric current okay that is your photoelectric current so here we shall discuss some points okay that is the first point is known as work function work function. So work function means I can take the symbol as W0. Okay. So it is the minimum energy required to remove an electron from the surface of the metal. As already I told you, the free electrons are present inside the metal surface. How much energy is required to remove this electron? So that energy is known as work function, right? It is the minimum energy required. It is the minimum energy required to remove an electron. Minimum
Sir, it
energy
is the
is
minimum.
required. Energy. Minimum energy required to remove an electron from the metal surface. To remove an electron from the metal surface. Okay? So this work function, the formula is W0 is equal to H into nu 0. What is the nu 0? Who can say? This is
Threshold
H,
frequency.
threshold frequency. Yes, very good. The work function W0 formula is H into nu 0, where H is known as Planck's constant.
Planck's constant.
And its value is 6.62 into 10 to the power minus 34 Js. Js means joule into second. Okay? And nu 0 is known as threshold frequency. Okay? So what is the formula for work function? Ashirbad? Ashirbad, what is the formula for work function? H into nu naught. H is known as Planck's constant. Nu naught is known as threshold frequency. So next point, right? What is threshold frequency? What is threshold frequency? Right. The minimum frequency due to which photoelectric effect occurs. The minimum frequency due to which photoelectric effect occurs is called threshold frequency. So just someone asked, sir, what is the meaning of this suitable frequency? So no ordinary light can eject, can remove the electron. Only there are certain light having suitable frequency. So that suitable frequency is known as threshold frequency. Means it is the minimum frequency due to which photoelectric effect occurs. So photoelectric effect occurs means there will be removal of the electron from the metal surface. Okay? Pragya, लिखिल चलो.
Yes, sir.
कौन लिखला पढ़लो?
The minimum frequency due to which photoelectric effects occurs is called threshold frequency.
Very good. It is known as threshold frequency. The different metals have different threshold frequency. So next, right, what is stopping potential? STOPPIN.
Sir,
Stopping potential. The next line is stopping potential. So stopping potential means I can take the symbol as V0. The stopping potential is one of the negative potential, right? The negative potential due to which stopping potential. The negative it is a negative potential due to which photoelectric current becomes zero. So photoelectric current becomes zero means there will be no emission of the electron. Okay. So photoelectric current becomes zero, or we can say no photoelectric effect is called as stopping potential. Okay. So next, right, laws of photoelectric effect. Laws of photoelectric effect. Laws of photoelectric. Number one. Very quick process. Photoelectric current. Electric current. So photoelectric directly is directly proportional to the photoelectric current is directly proportional to the intensity of incident light.
Yes, sir.
So what is the second point?
Photoelectric current is directly proportional to the intensity of incident light.
What is the meaning of that? Who can say? What is that meaning? Who can say? That means photoelectric current, IP. We have taken what? IP. The IP is directly proportional. IP is directly proportional to the intensity. If you have a more intensity, then more electrons will be ejected. If more electrons will be ejected, then current will be more. Okay, that means if you increase the intensity, then only current will be increased. If you decrease, it will also decrease. Okay, so photoelectric current is directly proportional to the intensity of incident light. And instantaneous means very quick process. Don't think that as electron is taking rest, the photon will come and interact with the electron, then only electron will be ejected. No, it is an instantaneous process. Number 3 point.
Sir, sir, which symbol that you have used, that intensity?
Intensity means capital I. Capital I stands for intensity.
Yes, sir.
Number 3 point, right. So if intensity will be less, current will be less. अच्छा कौन लिख ला photoelectric current is directly proportional to the intensity of incident light, but independent of frequency of the incident light. Okay, photoelectric current is independent of frequency of light. It depends upon the intensity, but does not depend upon the frequency. Hello.
Yes.
Yes, sir.
Right. Photoelectric current is independent of frequency of light. photoelectric current is independent of
Yes, sir.
frequency of light. Excellent.
Yes, sir.
Yes, sir.
Yes, sir.
Yes. It does not depend upon the frequency of light. Next, 4 point. Stopping potential depends upon frequency. Stopping potential depends upon frequency but independent of intensity. Just reverse. Look here. Current current depends upon intensity but independent of frequency. But stopping potential depends upon frequency but independent of intensity. Independent of intensity. Okay. Okay. I think you have some space on the right hand side of point number one. Point number two. On point number two, on the right hand side, you have some space. You have to plot a graph. So graph means x-axis we have to take intensity and y-axis we have to take the photoelectric current IP. So what will be the nature of the graph? Who can say? What will be the nature of the graph?
Directly proportional. Straight line.
Directly proportional means what is the
Straight
nature
line,
of the
sir.
graph?
Straight line.
Yes, very good. So this is a straight line passing to the origin. That means photoelectric current depends upon intensity. And here the stopping potential depends upon frequency. The fourth point, if you draw the diagram, okay, so this is your potential versus current, IP. So who can say which one is the stopping potential? Here. This is the negative, origin right hand side positive, origin left hand side negative. This is the negative potential. This is the negative potential minus V0 at which the current becomes 0. Okay. So this is your high intensity and this is a low intensity. Okay. So stopping potential depends upon frequency but independent of intensity. So this is the stopping potential minus V0 where the current becomes 0. Okay. So another graph. So this is again the stopping potential and this is the frequency. Y-axis I have taken the frequency. Okay. So look here, we have different frequency or different threshold frequency. This is nu 01, nu 02, this is nu 03. Okay. So our point said that different metals have different threshold frequency. So this is known as your saturation current. Okay. So right, next point. Different metals have different threshold frequency. Different metals have different threshold frequency.
Sir,
Different metals have different threshold frequency. So
Sir, different metals have different frequency.
Yes, different metals have different threshold frequency. Okay, so for this, the graph will be like this. This is sodium, sorry, potassium, sodium, zinc. Look here, different metals have different threshold frequency. This is potential. Sir, this is nu. You take nu versus stopping potential, V0. This is nu 01, nu 02, nu 03. What is the nu 01, nu 02, nu 03? These are the threshold frequency. So I have shown you three different metals. For potassium, this is your threshold frequency. For sodium, the value is different. And for zinc, the value is also different. So this is the graph between stopping potential versus frequency. Understood?
Yes, sir.
So these are the frequency, because on y-axis we have taken the frequency. So these frequency are known as threshold frequency. The minimum frequency is known as threshold frequency. Okay? So different metals have different threshold frequency. So you have to remember how many points I told you?
Sir,
How many?
Five, sir, 5
Sir, 5.
points, sir.
Five.
So these 5 points you have to remember. 5 points are known as laws of photoelectric effect. Next, what is photon? We are saying about photon. What is this photon? As I said, right? Photon means this is one fundamental particles of visible light. So photon is one fundamental particles of visible light. That means the visible light possesses the particles. Like as I said, the atom consists of electrons, protons and neutrons. These are the fundamental particles. Similarly, in case of a visible light, the fundamental particles are known as photon. Yes. The energy of the photon is equal to h into mu. You have to remember, this is E is equal to h into mu. What is the h here?
Planck constant.
Planck's
Planck
constant.
constant.
Planck's constant. And the mu with the frequency. If you multiply h with mu, then you can find the energy of a single photon. Next slide. Einstein's EIN, Einstein's theory of photoelectric effect, PEE. Okay. So I tell you during what is the mechanism of the photoelectric effect. The photon, the photon will come and interact with electron. Okay. Then what will happen? The electron will be emitted. Okay.
Yes, sir.
Right. According to Einstein, the light of suitable frequency is incident. According to Einstein, basically this was conducted by Einstein in 1905. According to Einstein, when light of suitable frequency is incident,
Sir, light waves.
light of suitable frequency. According to Einstein, when light of suitable frequency is incident on a metallic surface, then each photon interacts with an electron. Each photon interacts with one electron and completely transfer its energy to the electron. Understood? The line बुझेला? According to Einstein, प्रज्ञान कौन लिखला पढ़ो टिके?
According to Einstein, when light of suitable frequency is incident, then his photon interact with one electron and complete transfer its energy to the electron.
Yes. तुम इसे भूल लिखिଛ. According to Einstein, when light of suitable frequency is incident on a metallic surface, is incident on a metallic surface, then each photon interacts with one electron and completely transfer its energy to the electron. That means the photon will give all its energy to the electron. Understood?
Yes, sir.
Yes, sir.
Thus, the electron gains energy. And this energy is used by two parts. That means the total energy will be divided into two parts. Okay? Okay.
Yes, sir.
And this energy is used in two parts. Okay. ठीक था से नेक्स्ट क्लास में पढ़ेगा
Yes.
क्योंकि अटेंडेंस हाँ
Einstein theory of photoelectric effect.
हाँ आइंस्टाइन थ्योरी ऑफ फोटोइलेक्ट्रिक इफेक्ट ये मुंडो का बिल्कुल सही है सीरियल नंबर 1 2
Yes, sir.
3 4 5 6 7
Yes, sir.
8 9 10 11 11 12
Yes, sir.
13 14 15
Yes, sir.
16 17
Yes, sir.
18 19
Yes, sir.
20 21
Yes, sir.
22 23
Yes, sir.
24
Yes, sir.
25